Good evening, Math Dragons, and thank you for joining me for Lesson 4, What's the Difference? You've worked a lot with adding integers, where we use the number line and the chips model, and now we're going to continue with subtracting integers on the same two models, both the number line and the chips model. So we went through quite a bit of this earlier today, but I am going to review, and feel free to pause the video whenever you're feeling stuck or need to rewatch a section. So earlier we did the warm-up together in class. And each of these were addition sentences, and we had to figure out which was the first term and which was the second term and so on. So I'm going to grab some writing utensils here and get ready. So in this one, we're starting at 0 and we go to the left 5. So that is negative 5. And I'm adding, so I'm going to the right 11. So I'm going to go to the right 11 spaces. That lands me at the sum of 6. If you recall, we also displayed this on the CHIPS model. I'm going to quickly do a drawing of the CHIPS model that represented this same problem. So down here in the empty margin, number 1, I need 5 negatives, and then I need 11 positives. And I'm already drawing them as pairs because I know I need to pair them up. Let's see, that's 5, 6, 7, 8, 9, 10, 11. Each time I put a positive and a negative together like this with the chips, I create a 0 pair. So it's like they don't change the value of the entire number statement. So now I have 5 0 pairs. They all kind of come out of the equation because the 0 doesn't change the value, and I'm left with 1, 2, 3, 4, 5, 6 positives, which we expect to because that's what the number line model told us to do. Next one, go to the right 8, plus go to the left 12. On the number line model, it lands on the sum, so we're at negative 4. With the chips, this looks like 8 positive, and then we need 12 negative. I'm going to start to pair them already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since I conveniently paired them out already, I've got 0 pairs all over the place here. I've got 3, 4, 5, 6, 7, 8 0 pairs, and what is left over is the solution. I have 4 negative chips, aka red chips, and that is the solution we anticipated. Now we have negative 6 plus negative 7. I went to the left 6 and I went to the left another 7. My solution, or sum, is listed on the number line model. I'm at negative 13. In chips, I would have negative 6, and then another negative 7. You're all the same color, you're all the same charge, so you're just going to put them together. All together, I have a sum of negative 13. Remember, an important term you need to know for this is 0 pair. It's going to make all the difference. Let's keep going. Let's look at the getting started together. It says each situation described has 2 different conclusions. Describe how you might model each on a number line. So you owe a friend $10. You borrow an additional 5. So you start at negative 10. And if you borrow an additional 5, are you going to go left or right? If you said left, you're correct. So you move left 5 units. Your friend takes away $5 of that debt. So you owe your friend $10. You still start at negative 10. And your friend takes away $5 of that debt. So do you want to go more to the left or more to the right? Is it getting better or worse? If you said right, you are correct. Move right 5 units. The temperature is -7. Overnight, it gets 12 degrees colder. So I'm going to start at -7. I'm going to get colder. Do you want me to go left or right? You said left. You're correct. Left. 12 units. Good job. How about the temperature is -7. During the day, it gets 12 degrees warmer. You're still going to start at -7. Now which way? Warmer. Which way do you want to move? If you said right, you're correct. Right, 12 units. You have charged $65 on a credit card. You return an item purchased with the card that costs $24. So you're going to start at -65 because you put it on the credit card. Then you returned an item, so money's going to go back onto your card. If you're going to get money back, you're going to move right 24 units. Let's try a different scenario. You charged $65 on a credit card. You purchase an additional item with that card that costs $24. Start at -65, and you're getting more negative. So move left 24 units. You dug a hole in the ground that is 20 inches deep. Your dog sees the pile of dirt and thinks it's a game. He knocks 6 inches of dirt back into the hole. Well, your hole was at -20, so you start at -20. But he put dirt back into the hole. So are you going to move to the right or to the left? Do you want to be a deeper hole or do you want to fill the hole? You're going to move right. Right 6 units. In the second scenario, he digs the hole another 4 inches deeper. You're still going to start at -20, but the hole is going to get deeper. Which direction, left or right? You're going to go left 4 units. Excellent work. So that was just a little bit of thinking through it, problem solving, without actually having to do many of the numbers, just using logic. Now today we had many of our classmates get up in front of the group and walk up and down the number line. Some of the things that are noteworthy is they started at the value of the first term, and when they did subtraction, they had to face down the number line, which really meant left. And one thing most of us highlighted was if you walk forward if subtracting a positive number, walk backward if subtracting a negative number. And here is what we ended up with. You start at 1, you face left, you walk forwards, and then you are at -2. You start at 0, you face left, you walk backwards, and you're at +4. You're at -3, you face left, you walk forwards, and you are at -8. You're at -1, you face left because you're subtracting a negative number, so you're going to walk backwards, and you're at +3. So we did all that in class together. You should have those notes already. Good. We'll keep moving forward. Then they give us many worked examples. Why so many? Let me point out why. Okay. I'm going to use yellow to represent positive and pink to represent negative because they're trying to give you every possible scenario. Here they have a negative subtracting a positive. And we talked about how the subtraction really meant to go opposite direction. So normally I would go left 6 for the first term, which is correct. And then it says go the opposite of +2. +2 would go right. I'm going to go the opposite of right, therefore I'm going to go left. The next example was a negative subtract a negative. So I'm going to go left, and then I'm going to go the opposite of going left, which means to go right. Then they did a positive subtract a negative. In this example, I go to the right 6, and then I go the opposite of going left 2. So I go right 2. So I'll go right and more right, which landed me at 8. So move 6 to the right, because the problem says to subtract, you go the opposite of adding negative 2. Go the opposite of adding negative 2. Well, adding negative 2 would make you go left, therefore go right 2 units. And if I were to predict next they're going to have a positive, maybe subtract a positive? Yes. They have a positive, subtracting a positive. So they try to give you all the combinations. You're going to go to the right 6 units, and you're going to go the opposite of going to the right, which would be go to the left. This is a little more what you're used to from elementary school. You have something and you take a little something away. You still end up with your solution right there. 6 minus 2 is just 4. So you move right 6 units. Then you go the opposite of moving positive 2. Go opposite of adding positive 2. So you're going to go left 2 units. Now we got to most of these here. We're going to walk through these again. Use a number line to complete each number sentence. We're going to go to the left 4. So I'm starting with a point at 0 and I'm going left 4 because it tells me to go to the left 4. I need you to go the opposite of adding negative 3. Go the opposite of negative 3. Negative 3 would go left, therefore I need to go right. The opposite of going negative 3. Which is going to get you negative 1. All right, go left negative 4. Go the opposite of negative 4. Well, another negative 4 would have gone more left, so now I need to go right, the opposite of negative 4. You should land at 0. Negative 4. You're going to go left, negative 4. 4 units left. Go the opposite of positive 3. Positive 3 would go to the right. The opposite of the right is the left. 3, I'm going to land here, so I'm going to go the opposite of positive 3. Where does that put us? If you said negative 7, you are correct. Go left 4. Go the opposite of positive 4. Positive 4 would go right, so do the opposite. If you said go left, you're correct. Where does that land you? Negative 8. Excellent work, dragons. go right 4. See, it's positive, so we're going to go to the right 4 units. Go the opposite of negative 3. Negative 3 would go to the left. I want to do the opposite of going that way. So I'm going to go to the right. I'm going to the opposite of left, which is right. Where's that going to land me? 7. Excellent work. Very good. Let's try a couple on the back. Now pause the video, try these few on your own so you can help prepare yourself for the test tomorrow. Once you have the solution, unpause the video so you can see what the correct answers are. Okay, I'm going to resume. It says positive 4, so I'm going to go to the right 4. It says go the opposite of positive 4. I would have gone to the 4 to the right more, but it says go the opposite, so I'm going to take that 4 away. I'm going to end up right back at 0. Go to the right 4. Go the opposite 3. 3 would have gone to the right. It wants me to go the opposite. So I'm going to be at 1. Just 1. These are traditional problems you have done in elementary school. Go to the right 4. Go to the opposite of negative 4. Negative 4 will go to the left, so I need to go to the opposite, so I need to go to the right. I need to go 4 more to the right. 4 more units to the right, the opposite of negative 4. Where does that put me? The opposite of negative 4. It puts me at positive 8. Good job. What patterns did you notice when subtracting the integers in question 4? Describe an addition problem that is similar to each subtraction problem. Subtracting 2 negative integers. Subtracting 2 negative integers. Okay, let's say I had negative 8 subtract negative 7. It is the same as negative 8 adding 7. Because I'm going to go the opposite of negative. Subtracting 2 positive integers. 6 subtract 5 is the same as 6 and then going the opposite of positive 5, which is like saying go negative. Subtracting a positive integer from a negative integer. Okay, I have a negative integer, and I'm going to subtract a positive integer. All right, I've got negative 8, subtract 7, positive 7. So negative 8, go the opposite of positive 7. The opposite of right would be left, so that's just like having negative 8 plus a negative 7. Subtracting a negative integer from a positive integer. Subtracting a negative integer from, okay, so if I've got a positive integer, I'm going to subtract a negative integer, like taking away the debt. So I'm going to go the opposite of negative, which would be to go positive. Let's see if the solutions are the same. Let's think about that. Go to the left 8 and go the opposite of going left. So you're going to go to the right 7. Where are you? Negative 1. What's negative 8 plus 7? Negative 1. Let's check it on the calculator to verify our solution. Negative 8 subtract a negative 7 is negative 1. Or negative 8 plus 7 is negative 1. All right, let's do 6 subtract 5. You know that. That's just 1. But 6 plus a negative 5. So 6 subtract 5 is 1, we agree. How about 6 plus a negative 5? Also 1. Negative 8 subtract 7. Negative 8, go to the left 7. No, the opposite of going to the right. So you're going to go more to the left. So you're going to press negative 8, subtract 7. You're going to be negative 15. Well, negative 8 plus negative 7 is also negative 15. Last one here to check. Go to the right 6 and go the opposite of going left, which means go to the right more. So that's going to be 11. And 6 plus 5 is 11. But I'm going to prove that negative one for you. 6 subtract negative 5 is positive 11. I hope you're starting to see some patterns here. And I'm looking for patterns in here. That's where the patterns are hiding. Excellent work. All right, let's work with some chips. Some class periods got to this, some didn't. The number line model and the two-color counter model used in the addition of integers can also be used to investigate the subtraction of integers. Subtraction can mean to take away objects from a set. Subtraction can also mean a comparison of two numbers or the difference between them. Using just positive or just negative counters, you can show subtraction using the takeaway model. For example, I can have 7 positive chips, as they have illustrated here in the drawing. First start with 7 positive chips. Then take away 5 positive chips. They're calling them counters, I call them chips. Let's see, if we have 7, take away 5, I'm going to physically remove 5. So I have 2 positive counters remaining, which they illustrate right here in this one. Now they start with, their next problem is negative 7 minus negative 5. So let's start with negative 7. I'm going to start with 7 red chips. And I can still do a takeaway model here. I can take away 5 red chips. I have 7 red chips. I'm going to take away 5 red chips. 1, 2, 3, 4, 5. I'm left with 2 red chips, which is equal to negative 2. They have shown that here in this illustration. You started with 7, they removed 5, you are left with 2 negative counters. Now, what are the similarities and differences in this problem? Well, both the problems are subtracting integers with the same sign. The first problem is 2 positive integers. The second problem is 2 negative integers. Where it gets more interesting and complicated at the same time is when we start to mix the signs. Now, don't forget our friend, the zero pair. Mr. Zero Pair. You're going to need 0 pairs in order to do these problems. The first problem in the packet . If you're following along in the packet, if you'd like to make any illustrations or follow their illustrations, I'm on M256, worked example, example 3. They say you've got 7. 7. To me, when they tell me I got 7, that means I got 7 positive, I got 7 yellow chips. Boom. It says, take away 5 red chips. I don't have 5 red chips. We need 0 pairs. We need to find a way to bring in 5 red chips. Well, I can't just bring in 5 red chips. Like, ooh, ta-da, I made a new problem. No, that doesn't happen. That's not a legal method. I'm going to move these here. If I want to bring in 5 red chips, I got to bring in their counterpart. I have to bring in the positives as well. Because if I do that, really what I've done is plus 0, plus 0, plus 0, plus 0, plus 0, and that doesn't change the value of the entire scene. So now I've just brought in 5 0 pairs. Oh. Now it says have 7 yellow, boom, take away 5 red. I can do that now. I brought in all this 0. 1, 2, 3, 4, 5. What is left on the board is the solution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's try another problem together. I'm working on example 4 from the packet. -7, subtract 5. 2, 4, 6, 7. It wants me to take away 5 yellow. Can't do that. I don't have 5 yellow, so who do I need? That's what I need. How many do I need? How many do I need? I'm going to need 5 pairs because I need to have 5 yellows. So 1 pair, 2 pair, 3 pair, 4 pairs, 5 pair. Now I have these 7 red, and I have all these zeros here. 7 red plus all these zeros is what? What value is 7 red plus 0? 7 red plus 0 means I still am worth 7 red. I'm -7. I am -7 plus 0. I am still -7. The value did not change. But now I can take away 5 yellow chips. The remainder here, what is left, that is my solution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 red chips, which means the solution is -12. How would you illustrate that? Start with 7 negative counters. The expression says to subtract 5 positive counters, but there are no positive counters in the first model. How can you insert positive counters into the model and not change the value? You can insert 5 0 pairs. So let's work on our model. I need a positive and a negative, a positive and a negative, positive and a negative, positive and a negative, positive and a negative. So if these were all little chips, I just put in 5 positives and 5 negatives. That's the same as having 5 0 pairs. Now I have to remove 5 yellow. So I'm going to take these here and take these out. So that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That basically means that -7 subtract 5 equals -12. And I showed you with the real chips too. So hopefully that helps. Let's just do a couple of these together. Draw a representation for each subtraction problem, then calculate the difference. Okay, we need 4 yellow. Take away 5 red. 4 yellow. 1, 2, 3, 4. Take away 5 red. I don't have 5 red. What can I bring in? zero pair. Take away 5 red. So I brought in 0 pairs. That doesn't change the value of my scene. And I need to take out 5 red. I'm just going to take these out. Which means this part is my solution. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I'm going to remove the 5, and that leaves me with 9. So 4 take away negative 5 equals positive 9. Now pause the video. Work on B, C, and D. These are excellent practice. When you feel ready, come back and see if you have the correct answers. Okay, I have negative 4. I need to take away negative 5. I don't have negative 5, so I've inserted a 0 pair here. Now I can take away negative 5. 1, 2, 3, 4, 5 negatives have been removed. My solution is right here. It is positive 1. So negative 4, take away negative 5 is positive 1. Next up, negative 4. Take away 5 positives. Take away 5 positives. I don't have 5 positives, so I'm going to bring in a bunch of 0 pairs. How many 0 pairs? 5. Okay, now, I have not changed the value. This is 0 plus negative 4. The whole value is still negative 4, but I need to take away all these positives. I'm taking all those guys out, which leaves me 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 negatives. 9 red chips. Okay, last one on here is we start with 4 positives. And it says take away 5 positives. I don't have 5 positives to take. So I'm going to bring in my friend the 0 pair. There's my 0 pair. And I need to take away 5 positives. 1, 2, 3, 4, 5. That leaves 1 negative. That is my solution. 4 take away 5 equals negative 1. It says, how could you model 0 take away negative 7? You could start with 0, negative, or 0. You could start with 7 0 pairs, because that is the value of 0. So that's 3, 4, 5, 6, 7. 0, take away negative 7. 0, take away, okay, so I need to take away all the negatives. So that means my solution is positive 7. Does it matter how many 0 pairs you add? It doesn't. I could have started with 8 because I still could take away 7 red. Does order matter in subtraction? Yes, order matters in subtraction. You cannot flip them. Let's draw this last model together. So 0, this whole thing is 0 because I have 7 zero pairs, and it says take away 7 red, and I can take away 7 red. 1, 2, 3, 4, 5, 6, 7. So then I am left with 7 positive, which is telling me that 0 take away negative 7 is worth positive 7. You've done an excellent job. I appreciate you visiting with me on this YouTube video so that you could prepare for tomorrow's test. And if you have any questions, come prepared at the beginning of class with your questions so that I can answer them quickly before we begin our assessment. I will be back later to do this one in a separate video. This one is good. I just want to shorten this video. So thank you again for joining me, and good luck tomorrow on the unit test.